Yeah, it's a midway point at this moment.
Hey, Asif, in the context of what you're talking about, could you share with us what the general timeline is for when the team would take on a holistic project versus the class projects that were being assigned out? Is there a difference between those two topics? Because, for example, like a team's going to go take on something and produce something as a team versus doing for that day one or day two assignment.
Yeah, so let me talk. That's a good point to bring up, Sarah. Let's address that. See, guys, one of you need to mute yourself. Let me see who's not yet. Okay. See, our situation is this. The canonical format of this boot camp, or the one that generally leads to quite a bit of success, is this. You form small teams, and I trust by now you have either decided to go solo or you have formed your team. How many of you have gone solo? Yeah. One person here is solo. Anybody else who's gone solo? Only one person. The rest of you are all in teams. So in the team, you have a choice. The first project, which is just the RAG, if you realize that the first project that I gave you, the scope of it was, once again, I have echoes coming in. Okay, so the scope of it is that you build semantic search, then you put it together with some document corpus that your team selects. With that, you put a UI on top, attach it to an LLM, and you get RAG. Right? That was it. Then, optionally and importantly, you put Elasticsearch, a traditional search engine, together with it, and you put a cross encoder. Cross encoder is something that actually is a topic for today. You enhance your first project to become a much more powerful RAG. Am I making sense? So this was your first project. So let's break that project down. This project, the degrees of freedom were you could choose your own corpus, right? Or what domain that you want to address. And I do know that some teams have picked up really good domains. Somebody has picked up healthcare. Some people have picked up like classical literature, and so on and so forth. So if you have not, the first milestone that every team should have achieved is you should know which domain, which corpus of document that you're going to work with. That is one aspect of it. Once you do that, you need to parse the documents. You need to feed it. And by the way, don't use a pre-existing tool like Llama Index or semantic kernel from Microsoft, any one of these, because then it will mitigate your learning. Do it from scratch. And as the feedback, the people who are in bootcamp too, they all are uniformly coming back with the same feedback. They're saying that their own implementation runs practically 10x faster than these third-party tools that claim to do end-to-end for you, right? So it's good to know how to build these things from scratch. So that was part number one. You had to take you had to take that and you had to chunk those documents. And once you chunk those documents, I introduced the concept of semantic chunking. That was milestone number 2. And then you had to do an embedding. So today what I'll do is literally that code or the solution walkthrough or tips. I won't give you the solution. Well, I've practically given you the solution. Those of you who have looked at the solution will realize that I've practically given you the solution, but I still left it to you to stitch it together. gave you the classes and you have to feed it together. But the next milestone was to do embedding of that to create vectors, embedding vectors, right? Use a sentence encoder. Now, what are the considerations involved in that? I'll talk about that. And the fourth part of it was that from there you had to use a vector index fast specifically to index it into create your own little vector index to search through it, to do approximate nearest neighbor search, ANN, right? Once you do ANN, now you can search. You have a search engine, all the pieces of a search engine. What you're missing at that particular moment from a pure search engine perspective is you have not hybridized it with a traditional search, right? Like as an Elasticsearch. And those are the considerations I'll talk about today, quite a bit actually, and as we talk about the cross encoder. Then once the search engine, the simple AI search engine is in place, next milestone is to create a hybrid search engine in which we take the best of AI search and we take the best of traditional search to create a hybrid search. Are we together? A hybrid search engine. And then you now have a full hybrid search engine. The next milestone after that is, which I didn't, which is the assignment that I was going to give you today, was that you add to not just documents, but you add images to your search from that domain, right? So for example, if you are you're writing about the history, world history, then there are lots of images that talk about the historical monuments and whatnot. And you can create vector embeddings of those historical monuments and the geographies and so on and so forth. And artifacts, historical artifacts, some, I don't know, 1,000-year-old sword or tool or hammer or whatever it is. Do that. So that now makes it a multimodal search. The next milestone beyond that, at that moment, you're done with search completely. Does this make sense, guys? You're done with search. The next milestone is to add prompting to that. Do you guys recall that we did prompting? Right. So you need to become skilled at prompting. We did the CoStar framework, a very basic framework. Now, what will happen is, as you move forward, and I believe I added those links to the course portal, perhaps. Let me see if I did. Yeah, I did, because I wanted to keep it very simple for this particular LLM one. You will notice that prompting itself is a big, big topic. It is not as simple as it is. Prompting has been evolving in the last 2 years. It has gone through rapid evolution. To give you a sense of how fast it is evolving, I'll show you what you will learn in the next bootcamp. You notice that here we literally start out with first steps in prompt engineering, like that itself is beyond what you learn here, followed by advanced prompting, prompt engineering. Right? That is going to come significantly later. So there are these pretty big frameworks, emerging frameworks that we will use for prompting, but not in this course. In this course, the idea is to learn to do everything before we learn to do them in a deeper way, in a more sort of a state-of-the-art way. So we do prompting. Now, once you put search and prompting together, search you call retrieval, now it brings about the possibility of doing RAG, retrieval augmented generation. So let's ask this question. One of the projects that I gave some of the team, one of the choices I gave to the team members was that could you just take the 400 odd videos, the video recordings on YouTube of my sessions, right? So that forms a fairly large corpus of text. Once you transcribe those videos into text, and I think I shared at some point, if you're interested, I can share that text corpus, though I encourage you to pick your own corpus. Once you take that, if there is a question, for example, how would you explain support vector machines? Then the LLM, as you know, these large language models, if you take, and by the way, throughout this course, do not use a commercial tool. So do not go to OpenAI, do not go to Cloud or Gemini or any one of these, Cohere or any of this. You have to stay within the land of open source. So you take an open source LLM, let's say, take a small one, Llama 7B, 7 billion parameter or 30 billion parameter Llama. Now, that Llama has learned from the world's knowledge, isn't it? If you ask it, what are support vector machines? It will come up with a very formal definition, which will be somewhat close to what Wikipedia has to say and a lot of the open textbooks on support vector machines have to say. But if you go back and look at the lectures that I've given, I explain support vector machines, right, using far more intuitive analogies. I take the analogy of a river bank and trees and houses, yeah, and the river meandering through a landscape, and how you can treat the river as a decision boundary to demarcate the two sides, the sides with the houses and the side with the agricultural stuff like that. So now the way RAG comes in is that you want an answer grounded in the corpus, in the text that you have indexed. So what you do is you say, here is a user question. We use the user question, the user prompt, to search into your search engine, come back with search results. Let's say you come back with 20 search results. You give it to the LLM saying, use grounded on these facts. Grounded on these facts, how would you answer the user question? Right? So what is the machine doing now? The machine is not answering the question just based on its world knowledge. You are using from the machine only its visual, only its language understanding ability, isn't it? And you're asking it to put aside its own knowledge, world knowledge. You're instead saying that first look into the facts that we have given you and look for answers in that. And if you don't find the answer in that, then perhaps you can fall back to your world knowledge. When you do that, you have retrieval augmented generation, RAG. So that was our next milestone in the project. Are we making sense, guys? Now, in the project, when you do all of these, you're supposed to, like in the beginning, you can do it as little experiments that, yes, I could do the search. Yes, I could do this. I could stitch it together. Now, the next milestone was to take it to production. Like, how would you do the journey of taking these things to real world deployment? That was the journey of the MLOps pipeline. So, which is something I sort of have spoken about it in the past, but today is the day when I'm going to spend quite some time on it. And I'm going to talk about RayServe. I have introduced RayServe. I've given it to you to learn on your own. Did I do that in the past? Right? And it depends upon how significant you folks feel that I should discuss it. The reason I asked you to learn MLOps and RayServe on your own is because I felt you can hit the ground running in doing your project. And you will have some background when I talk about this very large topic. So today could be one of the days when I'll talk about how in the world do you take all this to production? Make sense? Right? So those are the milestones that we'll talk about. Now comes the other part of the whole journey. Along the way, I give you guys some small projects. You can do this, you can do visual embeddings. Remember, we talked of clip, we talked of blip 2, Then we talked about, on Wednesday, I said we missed a topic, lava, and we did cover lava on Wednesday, but actually, I noticed that from your batch, the attendance was ironically, uh, was it high or low? Yeah, you guys were conspicuous by your absence. Right. So what it means is, I was hoping we could save some time, right, by moving past it. But maybe I'll spend some time going over lava. And my apologies to those of you. I know Jenna came to the lava session. She's one of the few who did. And we will do lava, right? And then we'll move forward. So today actually is a milestone, guys. After that, we'll move forward. What I want you to do is finish this first project. Then I'll invite every team to pick up something. You have a choice between, it's an elective choice. It's a bring your own project day that you can talk about. Bring your own project means if in your company, you are going to do something with all of this and you have a well-defined business problem, you want to talk about it, right? It is almost like it is what in graduate school we call the clinic hours. We will have clinic hours. We'll give you some guidance on how to, whether that, see that whatever project you do, it has to align to our learning goals. Right? Because at the end of it, we are in a learning curriculum. It has to align. So, for example, you can't bring something completely off. For example, you can't say, I'm going to do anomaly detection in financial data as an illustration, because it's not within our main track at this particular moment to find anomalies in time series data or something like that. But that's a different topic. So things like that. So long as it aligns, it doesn't have to exactly align, but it relatively closely aligns with our learning goal. There is a bring your own project option. I would suggest if you have something, bring your own project. The alternative to that, to bring your own project, is that I'll give you guys 2 or 3 small sort of interstitial projects, small projects to do with visual instruction tuning. And you can do those. They'll make you very familiar with things like Hugging Face and with some of the libraries. And Hugging Face has become a huge ecosystem now. You can become familiar with that. After that, we will actually make beyond. So after this sort of a in-between pause that I call in the middle of the course, to which we may give today's session and possibly some part of the next session in help defining this. We would like to move on to a completely new chapter. We'll talk about document AI. Document AI is, and I'll give you guys some projects on that. It is about, if I give you a scanned document, page, an image, what can you take out of it? And by the way, a document, the meaning of document is very general. So for example, I don't know, somebody has left, so obviously some student was eating this because it wasn't me. I noticed there's something called neutro gum, energy and focus, like powered with natural caffeine, balanced with blah, blah, blah. I can hardly make out what's all. So suppose I give you this, a picture of this, but you notice that I've curved it, right? So the text is not straight, right? It is curved. Can you still look at a picture of this, understand what is here, tell which part is a picture, which is a logo or picture, which parts are text, and have a pretty good reproduction, not only reproduction of the text, not just optical character recognition, but comprehension of the text. Right? Do you see the challenge here? Or another example is take a Coca-Cola bottle, can. You notice that it's on a curved surface and it might be written on an angle and things like that. Can you capture that and understand it? And can you do that in a multilingual manner? Right? Can you take a scanned page, know which parts are tables, which parts are figures, which parts are running text, normal text, to be able to take all of those apart in a document and comprehend that, and it's not just saying, okay, this is what I found in that, but to be able to reason with that and be able to answer questions. Right? So I could ask you this question, based on this, here's something. For example, do you see, like, for example, if I hold a piece of paper to you, I could ask, which of the following subjects is it talking about? That is an easy one, right? For example, is it an invoice? Is it financial? Right? Is it a political slogan? Well, as you know, the whole madness of elections is about to start, right? Or is it somebody trying to sell you a product, marketing, or something like that? Is it a scientific document? Or it could be find the flaw in the equation. Right? So suppose I give you on the hand is written an algebraic equation that supposedly proves some point. Can you, for example, understand it and find a flaw in that argument? So now you realize that you not only have to first figure out what is written on the page, but you have to understand it. You see that? Right. So that will be an interesting project that I want you guys to do. And once you have mastered that, what is the beauty of that? You realize that you indexed text into your machine, into your search. You indexed images into your search. But a lot of the writing is in not in digital form. It gives you the ability to digitize whatever it is that you have huge boxes of. Right? For example, and the one example that we'll take is we'll start with just handwritten pages with diagrams on it and see to what level of efficacy you can convert a handwritten page in your handwriting and diagrams into something, into a digitally understandable format, and then be able to index it into your search and retrieve those as search results. So do you see the practical utility of where we are going, guys, with all this? The next milestone in our journey will be that can we, and then we'll read quite a bit of research papers in this context. Our next milestone after that will be the two domains that we have missed. What are the other two modalities that we have missed? Video and audio. So we learn to do two things. Now the journey of audio to text, in how many ways can we convert audio to text? You could do a direct audio to text conversion. We'll learn about technologies, how you use the transformers, large language models to do that. We'll learn about the architecture of things like Whisper, which are very effective, actually. Interesting that it's called Whisper, because its impact is pretty loud in the speech to text world. It's sort of a de facto standard. It does a very good job. So we'll use Whisper to do that. That's one way. The other is if you do image classification, and I believe I did give you guys an image classification, sound classification problem. Image trees and yeah, pepper trees. So we'll do a sound classification problem also. There you will learn that if it is not speech that can be translated into words, into text, what do? How do you distinguish, for example, tell a dog's bark apart from a chirp of a bird or something like that? Now, these things are very relevant. For example, there is I don't know how much you're aware that the sound, the ambient sound, is actually quite often in cities recorded. Throughout the cities, many cities, for example, New York, You have microphones implanted all over the place. They are specifically looking for gunshot. Right? And those sounds go into a centralized place where experts are sitting and they look at the sound wave and they tell whether it was a gunshot or whether it was just a car misfiring or some metal dropping from the roof or something like that, a clang or something. Because you want to create as rapid a response as possible in case there was a gunshot, right? In case there is violence in progress.
Isn't that
so? Real. Go ahead.
Isn't it true of the Bay Area also? I mean, the respondent.
Yes, yes, everywhere. It's everywhere. Most major cities have that. So there, the impact is human beings. Obviously, when you get these experts, it's very expensive. The question is, can AI do that? And it turns out AI has a pretty good track record in this space. Right? It can look at sound and can tell with fairly high accuracy whether what you're looking at is a gunshot. And as you know, well, you know, there's a good and the bad from this. When you hear that the cities, the metropolitan areas are now getting under heavy surveillance, it's I don't know how you feel about it. It feels like a huge panopticon in which 1,000 eyes are watching you. Apparently, in London, every time you cross a street, you are recorded at least a dozen times by different cameras. Yeah. And the ambient sound is captured and so on and so forth. US also is getting there. When you go to, obviously, in some countries, there are pretty powerful AIs. Apparently, somebody told me that in some country, I forget which, if you jaywalk across the street,
China.
You cross China, is it? China. You look at your cell phone and lovely, they just messaged you, here's your ticket for jaywalking. Right? So these things are happening, these things are coming. So it does, while you're impressed with the technology, sometimes like California, by the way, wants to pass a law, or they're at least thinking about it, that if you exceed the speed limit, the car will automatically tattle on you and you'll be issued a speeding ticket. Right. So it will self-report it that you're speeding, and you'll get a ticket. And they're in some cities, actually, they're already putting now there's visual systems that are speed tracking. And the moment they notice that you are speeding, they'll just automatic ticket issuance.
That's crazy. Right? You can find the car reports itself that it's speeding. Why can't the car just say, hey, you're speeding and slow down? The government
Which
wants
is
to make
another
money.
thing. In California, they are passing a rule that all the cars must have governors that will limit its speed to no more than 80 miles an hour. They're actually trying to put governors in them, that you cannot exceed the speed limit by more than 10 miles an hour automatically. Like first phase is just limited at 80, and after that. So I don't know. It's very like much as I like the beautiful beaches of California, I'm not sure.
There's also a privacy trade-off, right? All of
Yes, exactly. Privacy, huge issue. Anyway,
I was saying it's you can't get the income then.
No, that's what I'm saying.
No, the state doesn't get the income.
that's right. No, I mean, I'm sure that state will make a rule that if it sees you across 80, they'll put the governor at 81. First issue you a ticket and then do that. Anyway, so the point is that the sound, classifying sound, understanding whether it is speech, even when it is not speech, is of high value. Many of you know that the marine biology has gotten revolutionized because of all this AI. But today, we are pretty much getting some sense of what the whales are talking to each other. We are discovering that whales are able to talk to each other across unbelievably thousands of miles. Their sound carries or transmits that far, and they're having a pretty good conversation across vast distances. Schools of whales, yes.
So, sometime back, I read this thing about audio if you have like multiple streams going on.
Yeah.
So in this particular thing, will we be splitting those different audio streams?
Oh,
I mean,
yes.
Like,
So good question. So with audio, so that is the speech part of it. So one of the things that it is called the cocktail problem, or
yeah, right.
what it means is that suppose you are at a party and at a cocktail, and there are many people having simultaneous conversations. See, human beings have the ability to zero in on your friend and listen only to what your friend is saying and cut it all out. But with AI can do that. But the interesting thing is, can you separate out all the conversations simultaneously and record it as separate voices, separate things? The thing, we call it diarization and so forth. There's a whole technology. Is it done? It is done. Do you guys want to do it as a project? I can give it to you as a project because we can do the particular architecture that helps us do that separation of voices, diarization. It gets a little bit like, from my experience in the past camps, people do feel stretched because it becomes slightly longer project. But if you're interested, by all means, take it as an optional extension. It's not that hard at all. In any case, I can cover the research papers, the core research papers in that area, for diarization and for voice separations and so on and so forth. We can do that. And by the way, today all these tools like Whisper, they come with those things built in. Right? So that is on the voice front. Then on the video front, can you automatically do video comprehension? That's a topic. So we have a long journey to do. Where we are going at the end of it is, I want you to create or be able to create in your subject matter an automatic expert, right, to which you can think of it as a professor, as an expert in whatever corpus of document that you pick, healthcare, whatever, that you can ask question. It will respond by looking into the corpus of documents, searching for the results, rag it out. It will give you an answer, and you should be able to feel reasonably assured that it is not hallucinating. Because the big problem with LLMs is it can hallucinate and it can give you wrong answers. So, so the thing is, see, it's hard to take a system to production that hallucinates, right, that adds things of its own that are not there. As, for example, Air Canada discovered, right, their LLM managed to give a discount, right, that Air Canada imagined wasn't aware of, and they had to honor it. So there are many aspects of it, the legal aspects and so on and so forth. That is the scope of this basic bootcamp, the first bootcamp. Right? I want you guys to do all of that because as a foundation for those of you who get motivated and want to take this further. For the second bootcamp, which goes into all of these things. See, in the first bootcamp, right, we are getting introduced to all of these areas. We are not focusing on to what depth or what sophistication or robustness or perfection we are doing these things. Just do it because it is becoming familiar with these areas. One way or the other, have an implementation. Right? Don't shoot for perfection, as they say, right? Let perfection not be the enemy of the good. In the second bootcamp, you actually will cover similar territories, but you'll do it with full rigor. Each of these topics, because you know it, will go much deeper and do it right. That's what the folks in the other bootcamp are doing at this particular moment. You will also, so what is conspicuously missing in this bootcamp is things like fine-tuning, model fine-tuning, which is a vast topic, complete model training from scratch. Right? There are many, many areas that we are not touching upon. Advanced prompt engineering, agents. Agents are huge at this particular moment. Right? And we are literally, the 2024 may be the year of the agents, AI agents. So none of these I've kept in scope because, as you can see, it's 6 weeks in, and we'll come as we talk. Let's see how far each of the teams have come in implementing things. Right? So this is the scope of the whole course. Any questions? Any questions on that? Now, I notice that some of you have been reaching out very actively to the teaching assistants, but a large number of you have hardly ever reached out to them. So remember, they are there. They're all here, and they're there to help you. If you need help, they will all help you. Right? I'm literally looking at the Slack, the Zoom list of people, and I see them there. They will all help you. So do reach out to them. Don't hesitate. Reach out to me if you feel unsure who to reach out to. Reach out to me. I'll help you, and then I'll connect you to the right TAs. These TAs are spending a lot of time. Like these TAs are spending close to 10-15 hours a day helping people. Yeah, not 10-15 hours a day, 10-15 hours a week they are spending helping people. Right? So if you're not benefiting from that, now would be a good time to start benefiting. So any questions before I start now walking through the first project step by step? Any questions, guys? No questions. A pretty quiet audience. That makes me worried. It means I don't know how much progress have we really made then. So let's start with this, with the basics. I'll handwrite it. We will now, we have the code, but I'll take you guys a little bit deeper and ask you questions about whether your implementation is correct or not. So when it comes to parsing,
You make it black.
oh yes, let me make the whole color black.
Yes, please.
Sorry, 1 second. Insert, where is the color plot? View, page color, more. All right, better. So, 1 second. And this should do. Okay. The first part, you have documents. So tell me, step 1, collecting documents. Collecting these. How many of you have created a corpus of at least 100 documents? How many teams? This is why.
Three
Not
documents I have created, not 100.
Again, how many documents did you say?
3. I mean, I was just testing out the program. So,
See, guys, I'll tell you one thing. This is it does come up. See, if you gather only 3 documents, unless they are massive documents, right? You won't gain the benefit. What are you searching for? If you take world history, in 1500 pages, maybe you'll get something out of it, right? Or an encyclopedia, you'll get something out of it. But if you want to make this realistic, pay more attention to it. Guys, let me give you a fact. You want to hear some facts about the job situation today? If you're doing software engineering and that's all you know, right, you are a dead man walking. Right, your job is gone. Right, wait a year or two. If you haven't been laid off, they're coming for you. It's a fact. If you're just doing basic data analytics or data science, right, the market is so saturated. People are being offered, literally. People are doing it at, guess what the price points are? Anybody knows? I know the latest market data, but let me see how many of you are aware of how fast the world is changing. What's the price point for a typical just data analyst or basic data scientist?
Close to minimum wage.
Yes, close to minimum wage. It's about $30 an hour, $30 to $40 an hour. Right? What does that translate to? $30 an hour in a day translates to $240. That comes to some $5,000, $60,000 a year or something like that. Right? In California, that will put you in get you evicted. That's probably just the rent in Bay Area. Right? If you are doing more than that, let's say standard machine learning engineering, but you're doing random forest and this and that and so on and so forth, working with tabular data. What's the price point? Anyone knows the data? I'm telling you because of people come and tell me they got this job, they got that job, this is it, market is this good, this bad. So I do get a sense of the data. You get offers at this particular moment in the range of anywhere from 60 to $120 an hour. Pretty good, right? Livable wage here in California. And whatever is true in California, my guess is that on the other side of the Rockies and for the rest of the place, all the way to New York, probably excluding New York City and Boston, it's more or less this half of what you're making here. People make it. Is that a reasonable assumption, guys? Anybody who has hopped onto the other side of Rockies can attest to it? Or compensation is significantly lower there, right?
Asif, I agree on 110%.
Yes, yes. So that's that. And how much do you think people who know LLMs really well, what is the most important use case of LLM that the entire industry is adopting at this moment? The big wave. Gen AI. Gen AI. And what is the use case in Gen AI that they're all adopting? RAG. Right? See, guys, 20 years from 2003, 2004 to now, the staple diet of machine learning, the one problem that machine learning was solving. In fact, Silicon Valley was just a cottage, in many ways, a cottage industry doing what? Recommender systems. Advertising is recommender systems. Retail AI is recommender systems. Right? Whether you're buying Zillow is recommender systems. And all of these. Recommender systems was the dominant use case of machine learning. You were doing many other things, this classification, that classification, but there was a lion's share. If you knew how to do recommender systems well, you had a job. Even today, you have a job. The only difference is that now we do recommender systems with LLM. In fact, you did sentence embedding. The state-of-the-art recommender system is using the project, this project that you just did. The state-of-the-art recommender system today, all of them use semantic search. That's what the music streaming company that you're streaming your music from, your social media companies that are sending you recommended notifications and so forth. That is what they're using as one of the core ingredients. They're using a couple of other things, but you have learned that. So recommender systems, its state of the art is this. I am saying that because I am advising some of these places. Literally doing this. So this projects, guys, you're giving your Sunday to this and your week to that. Right? What I'm telling you is if you really take this sincerely and do it, I shouldn't have to. You guys are all professionals. You guys are busy. I know your employers are keeping you very busy. But believe me, the same employers will not think twice before laying you off next year. However hard you work. They will lay you off. Take it from me as a guarantee. In a year or two, they'll lay you off. Okay? So use the 80-20 rule, work in your current job, work hard, but invest in your future. This is your future. Seriously. I'm preaching to the choir. The very fact that you guys are here means you at least see in principle, you see the importance of it. It's just that you guys when I see that step one itself, you guys have made no progress, that's deeply disappointing. Sorry if it looks as though I'm talking down to you, but that's my job. I'm giving you a wake-up call. This is the use case that will get you a job immediately. Why are you not taking this seriously? Right? Now, the second use case that the industry is going after, literally, is RAG. RAG is a use case that every company has realized all this big, whether it's a consulting company, whether it is IBM, Deloitte, and all of these guys, PricewaterhouseCoopers and so forth, or Ernest Young's and so forth, or whether it is a software house, or it is a like things like Cognizance and the Infosys of the world. Look at where they're investing their money, right? They are all going to every single company in the world, whether it's in manufacturing or it is in pharmaceuticals, and saying, you have documents, you have years and years of documents, and the old search engines are gone. There is a better way, RAG. Right? Let's do RAG. Companies like Khan Academy and many other companies like Perplexity AI, which is putting a layer over Google searches, etc. At the end of it, RAG is the core engine. They have other things, but this is pretty much at the core of what they're trying to do. It starts with RAG. Do RAG, guys. Do it seriously. Don't just and I shouldn't have to give you the solution. I mean, see, the point is that you build it yourself. You'll have a sense of pride, and not only that, this is how AI interviews go. They'll do a technical round. Hopefully, this bootcamp prepares you to answer those technical questions. I do know that in the previous cohorts, everybody sailed through the interviews. They were asked to then show a portfolio of their work. What work will you show for unless you have done this work, done the work? They'll literally ask you, show me what you have built. Right? So build it, guys. Build it, please. So you can show that. Now, in this particular use case, guess what the compensations are going at this particular moment? Right? First of all, every single company at this moment is looking for people who are experts at RAG. Everyone, wherever you go for, almost all the interviews are about RAG. Right? And it's a blind leading the blind. The people, the interviewers who think they know, barely know it. Right? I'm getting some of the interview questions that people are being asked, and it is hard to tell if there was any part of the interview between the interviewer and the interviewee where a correct statement was made.
Asif, one quick data
There
point.
is that much just. Yeah, go ahead.
Yeah, I just got I happened to see the report today. The average enterprise spend in 2024 for primarily, RAG plus agents, all that Gen AI implementation is expected to be $18 million per company. Fortune 500. So they did a survey, and it was about $7 million in the experimentation state last year. Now it's bumped up to $18 million, which is 2.5-fold. So it's only going to go up, is what the report says.
So you see that, guys, $18 million average, you realize that that average is a lot of people, lot of companies, small companies, big companies, and so forth. So, so there's something very interesting about averages. If you know, does average speak to, does it reflect upon what a typical company, like a known company, mid-sized company making, let's say, 500 million a year or $1 billion a year, mid-sized company would be talking about? So I'll give you a hint. Can somebody tell me, whenever you have a long tail distribution, very long tail, right? For example, the compensation in your company, right, is whatever it is. If I ask you, what is the average salary or compensation of people in your company, and you compare it to your compensation, what will you find? You're above average or below average? Most of you. Let's see how well you guys get stats. Above average, right? Or below average? How many of you vote for above average? Would you guys feel that you're being undercompensated if your salary is below average? Actually, all of you
All
are
the time, right?
earning below
That's it.
average.
All the time you feel you're undercompensated anyways.
Yeah, that's a human psychology. But now I'm making a claim. Most of you, almost all of you, are earning below average. Why is that? What do you mean by outliers?
Top execs who make.
That's right. Right. So what happens is that beyond a certain rank, it's comp grows exponentially. Like zero start. Like in your case, you get what 5-10% raise a year. In US, I think the norm is nowadays 3-4%. Am I speaking?
0%.
What's that? 0%. Okay, 0%. Okay, 3-4%.
No, some companies are just holding off salary increases at this point.
That's right. That's true. So
This year also negative because they know the market.
they know the market and they're pushing down the comp. So by the way, it used to be funny. Like I worked hardest in my early years. Did huge work. I suppose I've been fairly hardworking. And then for the same amount of hard work, you notice that as you cross the decades, every decade later, one more zero adds to your comp. Right? I don't know. Some of you may have had similar experiences. Every single decade, 1 0 adds to the comp. So then you look at how much the CEO is earning. Right. So in the first company that I worked, let's say that my comp was in 6 figures. Right. It was my first job, and it was actually in the early 2000s. And for early 2000s to earn in your very first job after grad school to earn in your mid 6 figures was very good because of the stock options. Till I looked at what the CEO was earning, and the CEO was taking home $1 billion a year. Right. Then I thought, well, okay, he's the founder. What about the next year? Then I looked at the next year, and they were earning just one less zero. Right. They were making enough money to buy entire islands and declare it to be their own country if they wanted it. Right. So therefore, if you believe that, so a machine learning question: when you see a long tail distribution, what should be the better measure? Mean and average are the same thing.
Standard deviation.
Standard deviation will just tell you how much fluctuation there is from the mean.
Mode.
Guys, okay. Mode, the most frequent number. Most
Correct.
frequent number will be some pretty. You will beat the mode.
Is it the median maybe?
Because the company is filled with janitors and something. Median is a better value. See, guys, look at this. I made a curve. So anyway, this is a digression. I made a curve. Think mathematically. This curve has a distribution. It's a long tail distribution, right? Right. Very roughly speaking, it will show a distribution of x to the some power r. Isn't it? This y is like this. You know that if you averages make sense when you have a sort of a linear distribution, right? Or a well-behaved distribution. How can I make it well-behaved?
Take a log maybe?
Okay, maybe I'll just give the solution. If I take the log, what happens now? Log x, isn't it? So what you can do is you can take the average of the logs, because that's linear. When you take the average of the logs, in simple terms, what do you call it? You call it the geometric mean. What is geometric mean? Right. So for example, geometric mean of x and y is what? This, isn't it? G is equal to this. If you take the log of this, you realize that log G is equal to a half of log x plus log y, isn't it? What have you done? You're taking the average of the logs. That's what geometry. Guys, did you ever learn geometric mean in school?
I was just about to say you are getting a taste of your audience by asking us this question.
Okay, all right. So I want to ask that today. I suppose I seem to be in a mood to scold you guys for not doing your projects. So anyway,
do you still think this group is worth that the millions of dollars you're talking about?
yes, I'm also having doubts about it. Guys, spare yourself up. So anyway, so what happens is that when you ask this
Kansas,
question, by
I
the
was
way,
only hoping you would answer this question.
so you can take the median because the median will be better. There are things like harmonic means, a geometric mean, and average. And people sometimes, by the way, I ask this question often in interviews. The thing is, if you take a long tail distribution, in this particular specific case, you can take geometric, it turns out to be better. So you have to look at the geometric mean. When you do that, actually, if you look at the Fortune 500 companies, and to Madhu's point, if the average is around 18 million, the other thing is also true. The Fortune 500 companies, just like the salaries of the executives, they probably are spending close to 200 million, I would give or take, on projects like this on AI. That's what I would say per year. That would be their real investment, right? So that's the way to interpret the data. Like when you see that, right, in your mind, the wheel should start turning and saying, okay, if the global average is this, what does it mean for the companies? Where you typically when you go for a job, where do you go? You either go to a startup or you go to a Fortune 500, right? A Fortune 1000 companies.
So most of this investment is saying on the RAG side. What are the use cases that come up at the top of your mind? Is it related to say helping the developers, product owners, and all as from a search perspective? I mean, I keep hearing
Use
the
cases.
investment, right?
Okay, let's talk of the use cases of RAG. I will do
Yeah,
that. Let me park that question and I'll answer it to you. But let me finish this discussion, guys. So when you see a particular distribution like this long tail, geometric is good. But in the more general case, and how many of you have taken ML 100 with me? Intro to, there you are. So you remember these two guys who were mathematicians and who happened to be brother-in-laws,
Yeah.
Box Cox. Right? So what you need to do is whenever you get, see guys, don't ever go with average. Media uses the word average pretty sloppily. Average doesn't make sense unless you have a bell curve distribution. Normal distribution. Right? Never listen to the average, but average gives you some information, like Madhu pointed out. Now from that, you can start turning the wheels in your head and ask, what does it mean in terms of real numbers? Right? If you can infer the distribution, like a long tail distribution, then you can think of what it is trying to tell you, right? And what it will look like. But there is a thing called a Box-Cox transform. What you need to do is you need to do a Box-Cox transform of the data so that it begins to look like a normal distribution and then take the average in that space, right? So take average on BC transform of data. That is the formal correct statement of how to look at it. Anyway, this is one of those little asides. I thought it's part of, in a way, I call it being a good data scientist, being a good AI engineer, how to reason about data. But anyway, leaving that aside, to your question, what is RAG being used for? That's a question, right? Okay, so let me hear some answers. How many of you know of RAG being used in your organization? What is it being used for?
Well, narrowing down the number of documents that you use for the feeds for
documents to read, for example, narrowing down. So one answer I got is by indexing all the documents, when a question comes, you can narrow down exactly where the answers are.
Yeah, by document, I'm talking about structured data.
Structured data you can drag into it.
Maybe double clicking on that. Is it like a company intranet search or is it like
internal? Usually, quite often.
Internal, right? Yeah. So
yeah.
What you've done is scrape through all the complete documents and offering that into internal search or specifically for any particular user group. It is not documents. It is for structured data. Basically, we do a RAG on the structured data.
Hey, Asif.
Structured data is basically tables.
Yeah.
Hey, what about editor? Because we open, for example, for software development, we there are like for example project, right? There are like so many files, and if we just try to search something, it will show what are the impacted files.
You hit upon a very emerging use case. One of the things is, guys, till now, suppose you had a directory. So imagine a code editor. You would do a keyword search, isn't it? And then all the files that contain that keyword would be quite frustrating. Now, what can you do? In your using your and those of you who use Copilots are already seeing the use of it. What can you do? Now, where is a good use of the, let us say, factory pattern, factory design pattern? You could ask logical, semantic question. And what will it do? Throughout your code base, it will find all the places where it has been correctly implemented. Right? The keyword being good, it will ignore the places where you screwed up. So that code editor is one good thing. So let me tell you guys the powerful use cases.
So customer success uses a lot.
Customer success, guy just mentioned, is very. See, guys, look at the things enterprises care about. What are their cost centers? First use case of any technology is not for top line growth, but for bottom line. Look at the bottom line. Bottom line means savings. Where are the companies spending a lot of the money? Typical company, every single company has a support staff, like customer support. What does typical customer support look like? A lot of people sitting in call center agents, they get a question, they run through the script, which script how to answer this question, isn't it? And if the question cannot be answered, they sort of look around, read the documentation, try to figure it out. Quite often the answer is there on the documentation portal. It's just that user doesn't have the time. They expect they can call customer service. Customer service agents also are low-tech people. They are people working for minimum wage. Quite often, they can't. So now what happens is all the documentation, product documentation, and troubleshooting, and bug fixes, like fixes for specific things. If they are all RAGed, if they are all into a RAG framework, now what can you do? Literally, whatever the user says, you feed it in, and out the LLM will not only look at the search results, but will synthesize an answer for it. Right? And a very good use case is something that Sachin Naik brought up. He's here. He brought up yesterday. He pointed out that apparently people are using Macs and Windows. So Mac, in its infinite wisdom, did a new update to the operating system, right? And that update locked many people's machines. A lot of the softwares they were using can't be used anymore. Mac did it for security reasons because they found that when you get an app from the so-called App Store, I don't use Mac, so I'm just rephrasing what he said. Then it goes and looks at all your private files. It can potentially. So what they do is they wrap it up into a thing. Unfortunately, because of that, he had lots of developer tools installed. Developer tools typically take much more privileged access to the machine, admin access to the machine. He lost a lot of those applications. They simply stopped working. A lot of people apparently are annoyed. Solution is not quite obvious. He went to ChatGPT, the paid version, and started asking targeted questions. What ChatGPT did is it started reading all of the Google, all of the Apple or MacBook documentation. It started reading all the Reddit forums, right? It read all the Reddit forums recent. It read the product documentation, and it actually came out with answers, according to Sachin, that was not coherently presented anywhere on the internet on how to solve it. It took him a day to solve it, but he finally, using the LLM, using the ChatGPT, it did help him get all his applications back working.
previously, like especially in the hardware companies where you have a lot of schematics and documentation around, now people are, instead of having like 50, 60 meetings to find out a solution, people are using Gen AI to just ask a question on, hey, this is what I'm trying to do with this, right? And it's identifying what exactly. So avoids like a lot of meetings.
That is right. So that is one example of literally a practical use of RAG. Another is, look at Khan Academy. Do you guys know of Amigo, Khan Amigo? Any of your kids using Khan Amigo? Do you know what that is? Do we know what Khan Academy is, right?
Yeah.
Khan Academy. So what they have released is a Khan Amigo, for which they charge, in which it's a tutor. You want to learn a topic, it will help the kid learn. By the way, it's pretty good. Use it. What is it? It is literally RAG, right? A very successful use of RAG for education. Does that make sense? Right. Now, our course portal has gone down, by the way, but as you know, Support Vectors has implemented its own tutor on AI. When it comes back up, we are very close to it because we have rebuilt the portal. We are using RAG. You can ask it any question and it will find the answer, synthesize the answer out of literally everything that I've taught in the last 15 years.
Yeah, Asif, so there is something called as corrective RAG. Is that something even better than RAG, or what is the?
No, I'm sorry, say that again.
Corrective RAG.
Corrective RAG.
C
That's
RAG.
what he said.
Oh, RAG itself has many variations. See, retrieval augmented generation, the initial version were basic. There has been many improvements to that. There is ARAG, there is RAG itself has become such a big field, Prashant, that I literally have on my shelf at this moment. I have these 3-inch binders. Now I'm on my 4th binder of research papers on RAG. Right? So RAG has exploded. It's become it's like recommender systems. How many research papers are there on recommender systems? Probably 1,000. So the RAG field has exploded. There are many things people are doing. But what we are talking about collective RAG is basically within the field of RAG, ways to make sure that the machine doesn't hallucinate. It is completely grounded in facts, right? It's there. So guys, RAG in medical domain, what people are doing is they're literally giving images, right? And they're having machines put interpretations to it. That's RAG, right? Because it's reading the medical textbooks, it's looking at the image, understanding the image, and coming up with some diagnosis for it. Now think about it this way: medical access to medical care, especially super specializations. Those guys are like unicorns. They're very expensive. And have you ever been hospitalized recently? By the time you come out cured, you have to mortgage your house, right? Right. So now that one of the biggest use cases of medical would be RAG. You see, guys, how it goes. Yeah.
I think the other combination of the RAG and the Gen AI is going to also kind of lead to a lot of new set of users.
RAG is Gen AI because the LLM is generating an answer.
So like marketing or communication.
Absolutely, marketing, communication, etc. And guys,
generating is
yeah. So one of the things, for example, it's everywhere, guys. For example, NVIDIA conferences happen. But guess what they are using RAG for? They do chip design. It takes 1,000 engineers to do a chip design, right? The new chip that has come out, Blackwell. Apparently, it took a team of 1,000 high caliber hardware engineers to design that chip. They don't even manufacture it. They ship it out to TSMC for manufacturing. But just the chip layout, chip design is 1,000 engineers. What they did is that all the documentation associated with it, they RAG'd it. And they are seeing a massive productivity increase internally from RAG. So RAG is everywhere, guys. Huh? And that is why the first bootcamp the dominant project that I gave you was multimodal RAG. If you want to sum up, what are we doing in this bootcamp? We are doing multimodal RAG, isn't it? As a core project, that's what we are doing. So it's very hot. Do that, do this, guys. It is like the jobs are plenty, while software engineers are being massacred. You know that. How many of you know at least one friend who has lost his job, a software engineer who has lost a job? Right? One friend who has lost a job. 3/4 of the class is raising their hands. Right? So software engineering jobs are already on a free fall. At the same time, how many of you have applied for RAG and not gotten a job? None of you have applied. You haven't even done your project. How can you possibly apply?
We get dragged in the interview.
Yeah. So guys, you know, you're giving you. I am giving you a tough time deliberately, guys. It's a reality check. It's a wake up call. When I ask you, have you, as a team, found your document corpus, this is where it begins, and you guys are saying, the best that I hear is I've gathered 3 documents. That is not an answer. That is basically, yeah. Go ahead.
I said, sorry to disappoint you. I think we know what we want to feed. We are still trying to make the code work so that we can feed whatever we want.
No, start with first. At least have a directory of documents.
We need hundreds of documents. It won't scale.
The iteration time is like every code change we are trying to do is.
Yeah. So I'll talk about that. I'm going to talk about that.
We are trying to finish our working model with less data set. I'm hoping it will just scale when we give 1,000 files.
Okay. That is a very, very sorry excuse, because I'll tell you why. So people are saying, those of you who are remote, people are saying that, oh, the iteration time to take a document, chunkify it, embed it, is so long that we are slowed down by the process. So I'll tell you why that doesn't work. The solution, and I'll finally release the full solution in production on this machine, which is what I'm teaching you how to do. You can throw in 1,000 documents, and in under 30 seconds, the entire thing is available within your RAG system that is live, without taking down the system. That's the benchmark I'm taking you to. And I'm saying, and by the way, I'm not talking about running it on a H100 in the cloud or something. I'm talking of running it on the machines that I've given you guys. So you can take 1,000 documents and go live with it in under 30 seconds. How is that possible? Right? So that is exactly what we'll talk about. We'll learn about that today. And there's a practical aspect of it. So see, guys, all the theory you may learn, POC, in this field, there's an interesting paradox. The world is filled with, if you go to Medium or any one of these blog sites, you will find that short, very shallow articles on any one of these topics. It's hard to avoid them, like they're by the thousands, right? Or POCs, they will all say, look, Ma, I can fly. Like basically, I can do RAG, I can do this, I can do that, right? And they will all give you POC code. POC code in this field is easy and getting easier and easier with the open source tools. Building a production system, the success rate is very, 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 very low, very low. See, in software engineering, there was a crash report in year 2000 that said that 1 in 20 greenfield software engineering projects succeed. By greenfield, it's from the ground up product implementation. That is also the success rate, more or less, of startups. 1 in 20 startups succeed. Right? So in AI, the number is even more depressing. Whichever company you talk to, surely they have 1 or 2 or 3 data scientists or AI machine learning engineers who will tell you they have already done a POC. They are getting 80, 90% accuracies or whatever it is. Look, we did it. It's working. What about taking it to production? Right? Taking these things, creating a full ML pipeline, and doing it right such that it actually scales. See, guys, the hardware is very expensive, very, very expensive. You're not doing it in commodity servers. You're not just ordering a super micro server with some CPU and a half a terabyte of memory and running with it. We are talking of machines in which every GPU is $30,000. You realize that, right? So compared to the price of the GPU, everything else is negligible. It's a rounding error. By the time you end up putting 4 of these or 8 of these in a production system, you can at most afford 1. As a company, as an individual, of course, you can afford none, right? To be able to have a positive ROI on that investment, to create a software stack that justifies that expense is not that easy. And that's what we're trying to learn. Yeah. Are we making sense, guys? So do this bootcamp seriously, guys. You'll walk away with an ability that will make you a hot commodity in the market. Literally, you'll be one of those few people who know how to go to a company and build a product stack that doesn't bleed the company financially, that builds a reasonable ROI. So I've said enough. Now let's go through the process, guys. I don't want to wait for future. Each team, which team do you belong to? What's the name of your team? Vector Smiths. Vector Smiths. What domain have you picked?
Food.
Food. How many documents did you gather on food?
They're very big. Very, very big.
How big?
Probably 100 pages.
100 pages you call big?
No, they will more.
It's hard to find a book that's less than 100 pages these days. It's called an article.
Like the Stacy framework was even unable to chunk your files, they were so big.
No, that's not true. Spacey is lightning fast.
So
Something you're not doing right.
The default has a 10 million token limit for Spacey. So we have to increase the default limit.
But why are you doing it? Why are you giving? So this is a practical thing. I'm getting here in the audience a limitation that Spacey has a 10 million token limit. Remember one thing, guys. You don't have to feed the entire document as one input. You can break it up and send it in pieces.
I mean, we're doing that. We're just saying the example of how big the file is. We found the solution.
Okay. So vector smiths are getting nowhere. How many documents have you gathered?
6.
6. Okay. Can you guys take this as a task today, right? By end of the day, on food, get to 100. Good quality documents. See, guys, you're investing your Sunday, you're investing your week, your time. Why not come out with a product that you can actually showcase on GitHub and write a good article on? Write a good Substack or Medium article on that will actually get some reasonable claps. You can do that. It's not that hard. So goal number 1, go get 100 documents on food. Right? Beware, food is my area of expertise. You can make out from my big paunch. So I love cooking, by the way. So beware. So food, vector smiths. Can I expect this? What are you using for chunking? Like, what are you using to parse it? Are they PDF documents? What are they?
Combination, both text and PDF.
Text and PDF. Plain text and PDF.
Yes.
Right. Okay. This is what you have. Do you think you can reasonably reach 100 good quality documents on this? Achieve that goal, guys. Today, let it be. Actually, I was going to teach you guys a lot of research papers. It's proving counterproductive. You guys are not doing anything. So today we'll just do this. Which parser are you using? Tika, how do you convert them into plain text? How do you convert your documents to plain text? Okay, so while you guys are figuring it out, another team, Ganges, which team are you in?
Heisenberg.
Heisenberg.
Pretty uncertain.
Yeah, Heisenberg has an uncertainty around it. What's your document count?
20.
20. On which topic?
It's on English history.
English history. British history.
They're using space. No, I mean like language is English.
Oh, history.
History. You just do downloading from the Gutenberg.
So you're taking the whole world history, is it?
Category is history from
Right.
Gutenberg.
Gutenberg. You probably are aware of open access. So you can go to Gutenberg, but you can also go to a lot of OpenStax, for example. Are you aware of OpenStax? OpenStax. So there are many sites which give you open access, and they are excellent textbooks of greater than 1,000 pages each, with lovely pictures on world history. World history. Now, let's say that there are about 187 countries in the world, give or take. Right? Are you also gathering the histories of those countries individually?
No, actually, like we are downloading given a category and the language. So Gutenberg has an API that can download all the books in there.
How many books on history did you manage to get?
It's around 25, 20.
No, that's right. Do you think you can reach 100? By the way, if you go to OpenStax, etc., right, it is in no time you'll have exceeded 100. So guys, 100 is a minimum bar. Huh? You will see, you'll build something worthwhile. Reach 100.
Yeah, we'll take that as an
Yeah, please take that. Huh? And achieve that not in the indefinite future, but today.
but today.
Yeah, let's achieve that. So that's Heisenberg. And yeah.
And actually we are using Tika.
You're using Tika for parser. Tika is a good choice for parser. And guys, what I want you to do is on the Slack channel, help each other, please. Right? So if you guys are having environment problems, see, we can step in as the teaching staff, but it is far more collaborative, far more helpful if you guys help each other. Right? So for example, one of the nice things that Ganges did, which we didn't do, if you had asked us, we would tell you, go install Tika in this. The Ganges I think you just got the Docker for Tika. It turned out it was even easier than the way we would have recommended you to do. So would you mind posting your instructions on the Slack channel? Please do that. Huh? So I learned something. There's the beauty of it. I charge you tuition and I learn it. Right? Tika Docker. Right? Ganges will post instruction, that will be their contribution. And did you guys figure out what's your parser?
Yeah. So for text, we just use like
text
file reading stuff. For PDF, what we use is PyPDF.
PyPDF.
Just to read the whole file. After that, we use
Spacey. Just to convert it to text. Plain text.
PyPDF is what converts to text, right?
Text. And then you use Spacey to do what?
Sentence, identifying sentences. Not embedding.
Semantic.
Semantic sentences.
Oh, semantics.
Okay. Okay. So when it comes to semantic chunking, did you read the solution that I posted?
Yeah.
Do you note that I use a slightly different heuristics? I don't create chunks on just sentence boundaries. I concatenate the sentences back into.
Chunking is different from creating sentences, right? First we are asking a Spacey to create sentences.
Yeah.
I don't know the exact logic Spacey uses because we have used.
No, Spacey is very mature. So let me tell you how Spacey does it. The Spacey detects the parts of speech, POS, right? And it therefore knows where the punctuations are. So it does a very smart way of breaking it up into sentences. Sentence 1, sentence 2, and it does it in a multilingual way. So by the way, guys, Spacey, for your knowledge, is an industry benchmark. It is heavily used. It's very high performance. It's implemented in C Python, which means it runs at the full speed of C code. Yeah. So it is a great thing. It will give you sentences, but it won't give you semantic chunking. So semantic chunking you have to implement on your own. Did you implement it?
Yes, we did cosine similarity, and created chunks.
You created chunks. Very good. So you have made progress. It's just that you don't have enough documents. So you'll get enough documents. You have done all of this. Right? Now
we are lacking on the first part, but not the three.
Yeah. Okay. Which other team? How about you guys?
Project
Which
Yeti.
team?
Project Yeti.
Project Yeti. Bigfoot. How are the Bigfoots doing?
We just while talking, we decided on the topic of World War.
World War
1 and 2.
1 and 2. All right.
We haven't got the documents yet. So initially, we had like 10 documents, but
10 doc. Okay.
yeah, that's not regarding World War. We had other documents, around 10 documents, but now we'll be narrowed down to World War documents, and we'll be collecting 100 documents.
Sure. That is good. So that is Yeti. And how far have you gone? Which parser are you using?
Tika.
Tika. Good. And did you install Tika?
Yes.
And did you use a Dockerized version or just install Tika at work?
No,
Are you working on Linux or Mac or something?
So we have different people working on Mac, Linux, WSL.
Mhm.
So we are trying to set up a uniform environment with Anaconda thing. So I'm using WSL, and I was able to easily install Tika and all that.
Yeah. Good. So you're making progress. You're not stuck. You think you can today exceed 100 docs?
We will try.
Again, go to OpenStax. They have a lot of world history and war history docs. Gutenberg has it, of course, but also the OpenStax. Open access documents is you'll get high quality textbooks on these topics.
So what's the name of that website again?
All this.
Just look at, I believe it's OpenStax. I'll post it. Look at OpenStax. Open access. If you just Google open access textbooks, you will find OpenStax. So I'll post the links though. Yeah, go ahead.
Actually, where we were stuck was to set up the machine here and to trying to connect.
Yes. So guys, if you are using the machines here, two things. Some of these machines, by the way, have GPUs, some don't. GPUs have been ordered, they're coming, they'll have the GPUs. When you do this chunking, when you do the embeddings, etc., you'll need the power of AI, right? So remember in your code to make sure that you're doing it on the GPU. You're not doing it on the CPU. By default, all of the open source code, they will run on the CPU, which is probably the reason, I think one of you said it's running very slow, that iteration time is long. Actually, if you're running it on the GPU, to semantically chunk a large document will still take a couple of seconds. Right? See the guys, the performance difference between a 4090 and running it on an Intel or Metal or whatever, what is it called? Metal in Mac?
Metal is Apple.
Mac, yeah, Apple. Yeah. Or the difference between a 4090 and one of these things is the difference between an hour and half a minute. Right? Is that much difference. So you do want to do things. It's a reality of this world. These beasts that are made just for AI, these chips, right? They are so far ahead of general purpose computing. It's just not worth wasting your time on that. Make sure that you're using the GPUs.
One thing, somehow this whole VPN tunnel is not working.
No, yeah. So now we'll come to the question of VPN tunnel. Don't use VPN tunnel, guys. Use one of the things that people use is tail scale.
No, that is also a big problem.
Why is that a big problem?
It's never worked out for us. Right?
Tail scale?
Yeah, we spent a lot of time.
Yeah, we spent a lot of time setting up tail scale, and I mean, none of us had used it previously, so we didn't know how exactly to set up either. So by going through
So Hamad can help you there with the tail scale. See, guys, the last few cohorts, right? They have all loved tail scale. Tail scale is far easier than VPN.
Yeah, and then I think tail scale it asks for a paid version for more than one or something. And
no, beyond 5. If your team is more than 5, you have to pay for the version, but the fees is very nominal. You know, just have it for 2-3 months while you're doing the project, right? So tail scale is what I would recommend. If you're installing, by the way, on these machines you can install whatever you want. You can even do remote desktops, RDP. But if you install Tailscale, the previous batches of cohorts have said that Tailscale was the thing they found the easiest. That is one. Okay, so let me address the topic of VPN, guys. Practical VPN. You can do Tailscale.
One question, Asif. One question. So in our corpus, I just checked. We had 11 documents, right? And on my machine, it took more than 600 seconds or 10 minutes to chunk those 11 documents. And then it took a further maybe about 3 minutes or so.
Because you're not. No, go ahead, Mahesh. It took 3 minutes or so.
For the embeddings and sentence embeddings, right? But it took about 10 minutes or more, 10 or 11 minutes to chunk the documents, and about 3 minutes or 4 minutes or thereabouts to do the embeddings. So with 100, so I think we need to maybe either get the
And
GPU.
I'm trying to tell you that you can chunk and embed 1,000 documents in half a minute. And that's what I'm going to teach you today, how to do it.
Okay.
Mahesh, that's exactly what I'll teach you today.
Now, one thing to suggest, I've been setting up multiple ML machines in our server room, and I have a simple program that will report to me if that machine is set up running CUDA, so that I know it's going to go against the GPU. So as a team, if you haven't done a simple test program just to verify that your environment indeed is running against the GPU, I would recommend just creating a very simple test to verify that environment is what you would expect.
So, Sarath,
no, that's excellent that you have done that, guys. Yeah. So maybe you can. That's right. Sarah, it's nice that you guys finally are sitting. I mean, you set up your own local servers, I mentioned, right? With 4090s?
No.
Okay, so guys, pick your favorite.
No, they don't have 49. They do have a high-end GPU that we had available already. So until we run into stress tests that for the class and the labs, we're going to just go with those 3 machines.
All right, that is good. But they are CUDA capable, right? They are either 3090s or 4090s or A6000s or something. What GPUs do they have?
I can't remember the exact name. The index on the CUDA is 7.4, and I believe the 4090 is a 8.5 for performance ability. So they are pretty high end, but they'll do just fine for what we're trying to do at the moment. And they're about 40% or 40x faster than running on the CPU.
Oh yes, that's certainly true. I mean, guys, if like as Sarah pointed out, if you're running it on CPU, you might as well have a 2-year plan to do this project. It will take you a long time. Anyway, jokes apart. So guys, let's deal with one problem at a time. First is, on these machines, first make sure that some basic requirements are there. Let me create a section here. Must-haves or prereq. First thing that I would suggest you is, and this is where people will help you. See, Hamad is right here, guys. Ask him. And first thing you do is connectivity. How do you connect to it remotely? You have 2 ways. Use some VPN-like framework. I would suggest that compared to OpenVPN, Tailscale, the last batch loved Tailscale. Right? If you have a team of less than five or less, it's free. VPN, whatever. The other part is that you don't even need this. Install VS Code on the machine, and use VS Code tunnel. See, guys, I have to travel a lot, right? I am sometimes sitting in the airport lounges, right? And with some lame little laptop that I would have, I'm just tunneling into my servers. Right? It works beautifully. The good thing with VS Code is, so what does VS Code give you? Guys, please pay attention here. VS Code gives you a UI, but what you can do is the code is actually running on the server here, right? And you can open a terminal on the server here. So pretty much even this Tailscale or VPN you don't strictly need. The way a VS Code tunnel works is that you need your GitHub account, right? So the code server on the machine will tunnel to GitHub, right? And your VS Code will tunnel to GitHub also, right? So even though your machine is behind a firewall, you can still tunnel to it because this code server will initiate an outbound connection to GitHub. Are we together, guys? And you will initiate a tunnel to GitHub that will connect you to. So because of that, effectively, you have this connectivity. Now, those of you who are using IntelliJ or PyCharm, you have the same facility. I used to use for the longest time IntelliJ and PyCharm, but my recent experience has been that the momentum is towards VS Code. It's the big 1,000-pound gorilla in the IDE space. There's almost pointless fighting it. Right? For tunnel, etc., it does a very good job. So after using years and years of IntelliJ, I myself am finding that quite often, especially when you're traveling, it's just far easier to use VS Code. So guys, please do that. So this is on the connectivity side. The second point that I would make is on the CUDA, make sure
Previous I have a question. So
yeah,
the VS Code we directly connect to GitHub, and so in the from the laptop, meaning like
yeah. So what happens?
The server is there.
Yeah, right? See, okay, I'll tell you how it is. When you open a VS Code, look into the bottom left-hand corner.
Yeah.
There is a click. It will say connect to a tunnel.
Right.
And then it will say tunnel from where? It will say through GitHub. You give through GitHub. Because the moment your GitHub account remembers all the tunnels from the source server, code server, because on this machine, you started the code server, VS Code server. And so it is registered with GitHub. And this just looks up your registry of tunnels available in GitHub. So you could actually be running many servers, and at any given moment, you could be connecting to all of them.
So I'm doing this one, so
Yeah.
it's working well.
It's working well.
It's working well, but only I don't know whether it is like somebody is like doing something on the machine. I lost connection, and after that, okay, it became a little challenging.
Exact same problem.
Okay, so but that is solvable problem. But the ETS is able to connect, and I'm able to kind of do all the things what I need to do. Just to simplify this one, the GitHub is sort of like an authentication server for you. So basically, like you are authenticating to the server through GitHub, and everything is like from your local client machine, you can connect to the server.
No, so code server to GitHub, right? So how is that connection? We just check out the code?
No. When you start the code server on your machine, on this machine, right?
Even you don't need to. And I don't have anything like connected, my code is not connected to the GitHub yet, but I just authenticate. So GitHub is using just an authentication mechanism to authenticate you for the setting of the tunnel.
No, but you have to have the code server running on this machine. Otherwise, it will break. That's probably the reason you're breaking.
So
you need to have
that. So the tunnel that I turn on my server, if I restart the server, is the tunnel turning off that I have to keep turning on again and again?
Okay, so the question that is here is that what happens if you restart the server? I think the service stops. I don't know. See, On my machine, the uptime is months, so I don't.
So you have to
maybe find out.
Re-establish the tunnel.
Or you can put that in your service as well, right? So
Okay.
when the server comes up,
You're
it'll
talking to somebody who knows how to turn on and turn off the machine. You're talking service and I'll talk to you.
Yeah. So what you do is, just make it into an auto.
Oh, okay.
It's just tunnel service instead.
That is it. So yeah, Hamad has put all the instructions.
I'm trying to run the service as sudo or something.
No,
I'm
do not run it as sudo.
Okay.
Do not.
But I tried connecting and I wasn't successful even within my home group. So that is the problem.
Ah.
So there is a
So bring your machine, bring it over. We'll help you, right? That's when you reach out to us for help.
Okay.
Right? You reach out to us for help. If you're having any individual issues that others are not facing, classic situation. There's something unique to your machine. We'll help you. By the way, before I do, let me finish it. Are you by any chance on Windows?
Yeah.
Okay, if you are on Windows, all bets are off. Go throw that window in outside the window and get yourself a proper machine.
And one of the things,
I'm on Windows.
as if one of the things I would suggest is whenever you do any of this VPN things and all, to test it out, go on your mobile and create a hotspot, connect through that and then test it out. Because a lot of time, if you're doing it on within your internal Wi-Fi, they kind of escape it. And so you might think it's working, but later on discover it's not working. So that's the best way to test it out, as if like you're coming from outside. So create a hotspot and then try it out. So get it?
That's a good tip. Yeah, Sachin's comment
Just
is very.
question there, right? So when we do a remote in, can we try to find the external IP and then try to remote in? And would that be a more sensible way to try to do it instead of the 192.168 IP range?
No. These things, unless you're using Tailscale, there is no external IP.
No, as in if I'm remoting in, right, to the server, not using the tunnel of Visual Source, VS Code, but I just do a remote desktop into the server itself. 9 out of 10 times, when I'm within the same network, looks
Within
like
the
it's
same network, of course, it will work.
But
once you go home, it won't work. In fact, by design. See, guys, this place has a very interesting history. By now, you notice our data center has $500,000 worth of hardware sitting there. When I started this place, I was foolish. I mean, it's a matter of trust. How much everything was very open. And I'm talking about 2018, 19. Students complained that the machines, there's a powerful rack of $200,000 worth of hardware spinning. And I got the complaint that all the machines are so slow. Why don't you upgrade the machine? And I started scratching my head. What in the world is going on? How can this very expensive piece of hardware be running slow, right? All put together, just that rack, one rack, has over 2,000 cores and over 10 terabytes sitting in it. How can it be slow? And guess what was the answer?
You're not using GPU.
No, that was standard big data stuff. That was not even that was traditional machine learning. It was not even GPU driven. What was the problem? Can you guys guess?
Crypto was running.
Yes, somebody was crypto mining and pretty much was using all the resources at full capacity. Right. So you learn the hard way, that there has to be checks and balances. If you give a complete open access, and I don't believe, see, here's the thing. I would hate to believe that it was a student crypto mining. Most likely the student had a very weak password and the account was hacked and some outsider was crypto mining. Right. And you can't avoid it. It's a big temptation. You see 2,000 cores sitting there, right? 10 terabytes of memory, all at your disposal, and somebody else is paying the electricity bill. It happens. By the way, many companies are finding it that employees sneak in crypto mining workstations, put it under their desk, right? And they're running it on company electricity.
Yeah.
Right. It's the nature of it. So because of that, I can't have all this hardware openly accessed. Many of you have asked me this question. Can we please have direct access to this machine? without VPN, without any of this. Fact of life is not. Just recently we were hacked. The entire portal was taken down. We got hacked from Russia.
So another one.
So we live in very dangerous times, guys. Very dangerous.
Asif, I will also suggest people that
Go ahead, Sachin.
When they install any of these admin tools, the front-end admin tools to databases and things like that, which are coming from the open source. So most of the time, the surface vector comes from these Dockers, which have malicious packages installed. And they're usually in the JavaScript packages. So what ends up happening is they come through that in the main system and take over it. So be very careful when you install any of the front-end things. You go on Docker and install it from the open source. Just make sure that there are no vulnerabilities over there. And try not to install the latest one. Try to install whatever is the stable one, few months old. So be very careful about it. So that's a very, prime thing where they package in the Dockers itself. So most likely I have a suspicion, as if even your thing, it is repeatedly, if it is getting, there is some packages which have the vulnerability, which wasn't patched up. So check that. So have a little bit of a control.
Yeah, we need to.
Packages are installed. So.
Yeah, the new version of the portal.
Yeah. I do want to add from my experience. I think this direct access, moment you go, into something more large scale, like what Ask is trying to do, it just won't work. But practical example, Azure, we cannot open up. You can create a VM, but you can never SSH to it directly. It's disallowed from Intel policy. So what we have is something called Bastion Force, which is like actually running a web application firewall. So there's no other way. This is the way. The moment you go into a large scale data center,
you can't do
there's
that.
no other way out.
That's right. You have to set up jump boxes. You go to the jump box, from the jump box. So guys, all of you, you're familiar with your enterprise environment. Our situation is this, guys. I look at the log. Just this teaching server takes close to 500,000 attacks a day. That's a number of attack vectors coming in every day. Most of those are silly attacks, just blind bot attacks. But those are the dangerous times we live in. So therefore, please don't ask for easy access to these machines. These machines are there. This place is open from morning to evening. You can always drive up here, right? Or learn to use the VPN, learn to use the VS Code tunnel. Take care. Okay, the next topic is CUDA. Make sure, and the one that I would advise you to is put the latest CUDA that your hardware supports. If you're using the support vectors hardware, that happens to be 12.x. Install 12.x. Whatever solutions we will release, we verify that it is compatible with 12.x. Are we together? Right. CUDA 12.x. So take care of that. But if you have a different hardware, then apply whatever. So for example, those of you who are sitting on metal, whatever the, I'm told that there is something else called MPU for metal, Mac. Whatever it is, apply that. Though frankly, right, one fine day, despite your fancy Macs, you'll wake up and realize that if you want to do AI, you need AI hardware, dedicated AI hardware. Right? So that's that. So that's a second prerequisite, guys. The third thing that I would advise you, and that now I will get into it. Pick up 3. Become familiar with Docker. If you're not familiar with Docker and using Docker, this is a great time to do Docker. Why? Because it takes away the pain of installation and the installation not being correct and so on and so forth. Right? So for example, Tick-Off example is a simple install, but then Ganges here pointed out that all you had to do is Docker pull Apache Tick-Off latest, right? If you do Tick-Off pull, and then what do? You can just run it, right? Docker run. And when you run it, it's there on your system. You can stop it when you don't need it. No install needed. Right? That's the advantage. So become familiar with Docker, a baseline. Now I'll give you the fourth point, which is a new piece of technology that you may or may not be familiar with. Actually, the technology is very, very old. It is called compute pipeline. The two ones that I would recommend is A, either choose one, choose from something called Jenkins. Jenkins creates pipelines for jobs, right? So that brings us to the topic of compute pipelines, I'll do. Or you could use Airflow, which is more Python native, right? A more recent Airflow, right? Now, or C, whatever you like. What just happened? I had a, yeah, sorry.
Yeah, we couldn't hear you for a moment there.
Able to help you. Right? So remember, so I would suggest that unless you have a reason.
TV is lost.
Oh, TV is lost completely. The screen sharing has stopped. Very strange.
You just froze for a brief moment, Asif.
Yeah, and in fact, I lost the TV altogether. No signal. Okay, guys, remote guys, are you able to see me?
No.
Screen?
Yes.
Your monitor?
Good now. Yeah.
But here, the TV has, for some reason.
Now it's back up.
Yeah. Give me a second, guys. I hope I'm not having a hardware issue here.
Maybe they heard you again for crypto mining.
Oh, please don't scare me.
Profit sharing this time.
Yeah, I was rather pleased when this whole crypto madness was going away, but I'm told it's back up. It's again rising. No signal. So, or anyway, I do need to do some surgery here. Guys who are local here, just look at the screen on your, like zoom into the thing till I fix this. I'll fix this in the break. I'll see what's going on. But I want to finish this discussion. Let me see how many. Okay. Display settings. Yes, one monitor has entirely disappeared. All right, I will. And the application has disappeared. I don't know what's going on. Give me a moment, guys. It's Windows, of course. It's the only Windows on this prop in support vectors. I need it because Linux doesn't support the writing pad. All right, guys. So I would suggest Jenkins. So let me give you an introduction to Jenkins. And the same thing applies to Airflow. What Jenkins does is, see, let's look at your job. You have a document folder. You have some script, let's say some Python script that will read this document folder and it will emit out plain text. Is this what your code is doing, guys? Reads a PDF or whatever it is, converts it to plain text, right? So you have a script. What you want to do is, you don't want to be running it from the command line. Jenkins gives you a nice user interface where you define a job. That is why you will notice that there is a whole, in the compute subdirectory of svlearn, there are all of these Python scripts with whose suffix is job, extractor job, parser job, things like that, right? So those jobs, because that's a Jenkins terminology, it's a job and it will do this. And then the beautiful thing with that job is one job can trigger, please mute yourself, guys. One job. Yeah, one job can trigger the next job. So job 1 can trigger job 2, can trigger job successfully job 3. What does that mean? You can have the extractor job. It can trigger off the chunker job. Isn't it, guys? Chunks can trigger off the embedding job, vector embedding job, can trigger off the indexing job. Does that make sense? Index building job. So that's the beauty of jobs, right? Or Jenkins. You just click at one end, it will do that. Am I making sense, guys? Right. So today, if you're not familiar with Jenkins and you have not set up Jenkins, it is an excellent time for you to set up Jenkins. How can you do Jenkins setup? Many ways. Jenkins is a very one-click install. You can install it. Or better still, what's the other way? Docker. Get a Jenkins Docker, run it. You're done. Are we making sense? That is it. So the second thing that you need to familiarize yourself with, how many of you, by the way, have a Jenkins already set up to do this in the team? One team. Anybody else? By the way, Saurabh, what's your document corpus?
I'm with the Heisenberg. So
Heisenberg. Okay. And by the way, which team did I not cover? Shratik, what's your team?
Also with Heisenberg.
You're also with Heisenberg. All the brighties have gone into Heisenberg. Okay. I need to break up that team now. Too powerful. Okay. Bhavin, which one are you with?
I'm with Yeti.
With the Yeti team. And is there any other team that we haven't covered? There are only 3 teams. These look rather big teams.
I'm going solo and I haven't started. So.
Oh.
I'm also solo.
You're also solo. Okay. Maybe you can pair up. So I have Vector Smiths, Heisenbergs, and Yeti. And remote guys, do you guys have a name of your team? Sarah, you have a name for your team?
We talked some team names. I don't think we've picked one, and we haven't started. So we'll get to that today.
Okay, let's do that, guys. Today I decided that given the state of affairs with your project, it's better not to teach anything, but just make progress. So, Jax, pick a team. Which one you want to join? And Mahesh, which team are you in? Yeti. And
I'm in Yeti.
You're in Yeti. And Sanjeev, what's your team name? Sanjeev, I don't see, is not joined the meeting yet. Okay, so Suhash, which team are you in?
Heisenberg.
Say that again.
Heisenberg with Ganges.
You're in the Heisenberg. Okay. We need a few more teams. These are becoming big teams now. Okay, for now we'll leave it. So guys, today, right, learn the production. This is all part of going to production, guys. How to go to production. And now the next thing that you need to know is a database where you'll store all of this information. Right. So a very good database is MariaDB. Maria, unless you have DB or Postgres. MariaDB is the same as MySQL. MariaDB and MySQL are the same thing, more or less. They are like command compatible. You can go there, or you could do Postgres. All the previous cohorts, they have usually preferred one or the other. I've occasionally seen people say, no, they want to go MongoDB. Now, but pick your choice, whichever one you want, pick one, right? If you notice that in the sample code, I've given you the SQL scripts, right? The table schema in the SQL scripts. If you use MariaDB, you can just run the SQL scripts, you're done. Your schema will be produced. Why do we need the database? This database acts as your feature store. Right? See, guys, anything that you put in effort producing, for example, a PDF becomes plain text. What should you do? You should store it in a document table. You will notice that in the sample solution, there is a document table. It will have ID. Are we together? A primary key, and it will have the text, plain text. And it will also have the original file name. Does that make sense? Right. So what do you do? So what should your job do? When it picks up a PDF or whatever, Word document, HTML, whatever, you convert it to plain text, you insert it into the database, and you remember the original file name. Now, how do you make sure that you are not reprocessing the same file over and over again and making multiple entries?
Make it the primary key. File name. Database flag.
Yeah, what you do is, one trick that I would suggest you do is that, let's say that you have a source directory of source where people dump documents, new documents get dumped. Every time you process a document, move it to another folder called processed a process directory. Right? So then what happens is the very fact that the document has gone missing means you can't encounter it again and again. Isn't it? Now, in Jenkins, you can have all sorts of triggers. What you can do is you can have a cycle. The job will trigger every minute. Every minute, it will go and check the source directory automatically. If it finds something, it will immediately go process it. Does that make sense?
So can we also make the file name itself some kind of a key in the database so that even by mistake, if you pick the document again, you're not reprocessing it, although you moved it the first instance.
Yeah, you could do that, but what happens is that if you look at things like history, right? So many of the you'll have to then rename the PDFs or the source. A good idea, what people do is when they get the file, they change the original file name to something logical, and then they make it a part of the primary. You can do that. In database world, though, there is now I'm talking as a person coming from Oracle. There has been emerging wisdom from experience, which says that primary key should always be surrogate key. Right? What do I mean by that? It should not be something of actual business value, like file name. You should always have a completely independent surrogate ID. Exactly.
Like UUID or something.
Yeah, exactly. Right. That's the best practice for it. So this is a document thing. Now comes the whole question. If you do it like that and you use sticker, it's fast. But suppose I dump 1,000 documents and you do one document at a time, it's going to take a long time. Does that make sense, guys? You may say that doesn't matter, I'm fine with that. Or you can parallelize it. So now let's talk about parallel distributed computing. So this is the world of big data. So there are these big data technologies and libraries. Spark is a really good one, very often used. So I would recommend that you use Spark, right? PySpark. If you want to go Python, PySpark.
If you're using one machine, what's the point in using Spark?
Because it will parallelize it. A machine will have, let's say that, so look at these modern hardwares. Typically, these machines that I've given you, they have 32 cores, right? When you are doing one document at a time, you are using 1 by 32 processing capability, right? When you run it as a Spark, or even a one node Spark cluster, right? What it means is that you're processing, if nothing else, 32 documents in parallel, more like 64 documents in parallel or something like that, right? Twice that many. So your throughput is higher. Are we together? Now, if you go and look at the sample code that I've given, you will see that we are doing that. Right. Now, here is something that some people do. You can do that extraction code using Tika right there in the Spark code. Or what you can do is you can set up extractor, and both of these approaches are correct. I don't remember which one I gave you guys in the sample solution, or maybe I gave both. You can make extractor as a REST service. So suppose extraction is a REST service. What will go in? A text will go in, and what will come out? A document will go in, and a text will come out. I don't recommend that. For just plain extraction, it's not making it worth making it into a service, but your mileage may vary. I think you should just extractor, Tika extractor, for example, you can do. Now, Spark has a very good integration with the database. Right? So one of the things it does is that it will do the processing, right? It has a very good integration with the file system. So you just have to feed it to the file system. And whatever number of files it gets, it will automatically parallel process it. Right? Here is your compute, which is just a Tika extractor. Let's say. And what will it do? It will put it into your database. See, right? Whatever your database is, it will put it there in the document table. So guys, achieve this at least today. Get your Spark going. Do this part, especially when most of the code I've given it to you. Now that code will make sense to you. You'll see that all the pieces are there. Are we together? So Spark is the compute layer. The second thing we'll do is chunk, semantic chunking. Now, there is a basic rule, and this is the disconnect between big data frameworks and AI. See, big data frameworks like Spark, they're distributed compute frameworks. They assume that hardware is cheap and commodity, and you can massively parallelize. Right? You can run many tasks simultaneously. The GPU reality is different. What is the GPU reality? Very expensive, and you have only one GPU, right? You don't have a cluster of it. So GPU, whenever you have a GPU, what do you need to do? The requests need to be queued in production. What happens if you run multiple inferences at the same time on a GPU? Have you tried that? What happens? Very soon, you're blessed with a lovely thing called CUDA, out of memory error. It is the hell. The moment you see that, after that, you're stuck because no further jobs can be run. You have to flush the CUDA, flush the GPU. I mean, literally, you have an exception in runtime. Right? So what you do is you control that GPU, access to the GPU, and you make sure that jobs, only as many jobs as it can take go in parallel into it.
So in this case, are we going to run the Spark only in CPU? And
I would suggest run the Spark in CPU. Exactly. And so what you do, and this is where I introduce you to a framework, Ray, the Ray framework, right? So what you can do is this. See, guys, first of all, there is a framework called Fast API. It's a REST framework for microservices, creating microservices. Right. Use this. If you're using Flask, well, all I would say is move to Fast API. It is much faster. Right. Use Fast API. Now, if Fast API is, how many of you are familiar with Fast API?
Somewhat familiar.
Okay, some of you are somewhat familiar. So guys, you have a lot of learning curve. These are easy frameworks. And see, I'm introducing a lot of things, Jenkins, Spark, Fast API. But believe me, these are all easy frameworks to pick up. Jenkins is just a setup. It takes half an hour to become familiar with it. Those of you who know Jenkins, would you agree? Very easy, right? There's no programming. You just declare a job, like very visual, right? Then a fast API, those of you who know fast API, would you agree it's very simple to create a REST service? You can create a REST service, right? Spark takes a little bit of a learning curve. So budget some time to pick up Spark. Are we together? PySpark will take time. And by the way, it's a very valuable skill to pick up. It has been the industry workhorse now for more than a decade. Right? Spark is the distributed compute engine, right? Most heavily used. Then for
how is Airflow?
Airflow is like Jenkins. No? It's a orchestration engine.
Is it easy or on par with Jenkins?
Jenkins is dead easy.
Okay.
Airflow, you still have to write some Python code.
Jenkins is generally for like general purpose workflows and computation. Airflow is for data operations.
Yeah.
Generally, like Airflow used in connection with the Spark. So if you're running like distributed jobs, so you want to know the status of the job, whether it is still running or it's broken and stuff like that. So Airflow has that capability to see that. So
yeah. All right. So for those of you who are remote, the discussion here says that Jenkins is the easiest to pick up. It's a general purpose orchestration engine. The Airflow is much more often used with the data pipelines. True. See, Airflow is a slightly more learning curve, but at the same time, it's more modern. It's much more often used these days. Right? Consider Airflow as your stretch goal. Consider Jenkins as the easy one. I'll take your question. As an easy one. And Jenkins has a 10-minute learning curve. Why not start with that? Then switch over. Question.
I have a question about text chunker.
So we are not there yet. Hold on. Hold on to your thoughts. I'll come to that. Yeah.
Not about implementation. Let's say we are processing file to text, right? The PDF to text.
That is just extraction.
That is just extraction, right? With Spark, we are doing it parallelly, right? Once it is done, how do we notify Chunker that
you don't need to notify Chunker at all, and that's the point I'm making. See, imagine. So the question that I got from the audience is: suppose I have a text extractor that converts a PDF to text. How do I notify the Chunker? The simple answer is you don't. You write one job, right, which takes the PDF or many PDFs, PDF K, let's say K, and converts them into text, puts them into the database. It is done. Let's call it job one. Right? You have another job that takes a text or text 1 to text 10. For each of them, it creates chunks and puts it back into the database. Let me call it job 2. Then what you do is you don't notify. You in Jenkins create a pipeline. How? You register this job. What you do is you create a dependency from this job. This job is triggered by completion of job 1 automatically. When job 1 finishes, it will trigger job 2.
If 10 files are being processed, or they run as 10 jobs, or
no,
it's one
job will process all 10 files.
Okay.
So that's why it's a parallel. It's a distributed parallelization framework. It's big data. In big data world, this sort of things with PySpark makes it dead easy. If you look at the code that I have. So here's the thing. You will have a little bit of a mountain to climb. Maybe you'll have to learn the basics of PySpark. But once you pick up the basics of PySpark and you go and look at the sample code, the solution that I've given you, it will look dead simple. It's just this much of code. Barely 2 paragraphs of code. That's it. That does it all.
Okay.
Just curious question here. In the way you presented it, right? So we are waiting for job 1 to complete before job 2 starts. And
yeah.
if we are processing hundreds of thousands of documents, then isn't that becoming a more serial process? Instead, can we also run job 2 in parallel as job 1 is putting data into the database?
Yeah. See, one parallelization is that you create end-to-end for one document. right? And then do for the second and parallelize using that. Generally, it's bad because what happens is that, think about it this way. If it finishes just in the second last step, you'll have to restart the entire thing again. Whereas if you, let us say that right at the last stage, which is indexing, the job fails. You realize that you can restart only the last stage. So you should never do many things within a single job.
But as it with the message queue, it is doable, right? Like you can
that is another. So hold that thought. That's a very good point. Actually, from the audience, you get this thing. Can we do it using message queue? Those of you who are good with Celery or Kafka, etc., an alternative to Spark, you could do it with a message queue. Now, what happens is message queues are not very efficient to read from file systems and then in the consumer write to data. Writing to database is easy. The Kafka consumer or your Celery message queue consumer, you can do that. So message queue is an alternative thing. In the previous cohorts, there were people who tried using message queue and people who tried using Jenkins and Spark. Generally, people who did using Jenkins and Spark, they finished their project in no time.
Actually, for this one, I think Spark is the best thing.
Spark is very easy. Yeah, it's very easy.
Just we are doing the ETL down.
Having said that, message queue, there were people who implemented it using message queue, right? Because what they're doing is they're posting it to each stage. Like you have multiple queues, right? One queue into which you post the docs, another queue in which you post the text, another queue in which you post the chunk, right? So on and so forth. Another queue where you check the vector, right? And what will happen is that this queue will produce doc to text. This queue will produce chunks. Consumer will produce chunks. This queue's consumer will produce vectors. This queue's consumer will produce index.
But the benefit in this case is like all the processes are running parallelly, right? Chunks everything is running parallelly and they are processing everything. Right? You can continuously feed data.
Yeah.
But with job approach, it is step by step.
It is step by step. It is true. See, there has always been this thing between how to do distributed compute frameworks. Between Spark and Kafka, there's a huge overlap. And which particular framework people choose, sometimes it's convenience, sometimes it's simplicity. Right? If you're more familiar, if you're more familiar with messaging queues, go messaging queues. If you're more familiar with Spark, this kind of thing, go Spark. When you do this, right, you will notice that actually doing it with Spark and Jenkins, and this is the experience of the previous cohort, turns out to be somewhat simpler than going the messaging queue. For example, in the last batch, one person used Celery to do the whole thing. After a little while, changed over to Spark. Right? So that's it. Go ahead, Ganges.
Now, for the Kafka queue, if the document stream is continuous, then queuing is better. Sorry. Here, like we are going to download a bunch of documents, maybe like hundreds and thousands of documents. We want to process them. So it's one event at some time.
Speed is not continuous.
Yeah,
it's not continuous. So probably it may not be right.
That's right. So guys, today maybe let us have progress because you guys haven't made that much progress. It seems. Should we say that we learned these things today? We give to setting up our pipelines. Each of the teams will come and watch. You have your pipeline going, Jenkins pipeline going. You have 100 documents at least. Aim for 1,000, but at least 100. Right? We get the parsing, we get the chunking going. Right? And with chunking, I must say, so let me make this point now. Final point before I give you guys a lunch break. See, if you do simple chunking by fixed size chunking, there is no GPU needed. Right? You can do it just with Spacey, etc. Even Spacey, GPU makes it faster, but let's say. But the moment you use GPU, what I would suggest is make it into a REST service. The simplest one that you can use is Fast API. We give you the Fast API implementation. Now, Fast API also now contains queuing and throttling. So your request will get queued internally. You can throttle how many requests get processed, basically. but it's not as robust. But anyway, you can do that. You can do your semantic chunking because it uses the GPU. And so what happens when the Spark job loads the text file? What is it doing? It is making a call to the REST service. Sorry, this is a REST service, so I should mark it as service. Right? And gets the response and feeds it into the database. Are we together? It posts a text file to the REST service. It gets back a list of chunks that it feeds into the database. Right? And your REST service is stateless. I think in the solution we have given it to you like that. Right? That is it. Now, let's stay with just chunking, semantic chunking. I'll take questions in a moment. So all of you, I can see lots of questions on people's faces. Hold on. Because we made semantic chunking into a service, the gold standard is don't use fast API, use a dedicated compute framework meant for machine learning. Are we together? Which is very aware of the problems in machine learning, like GPU constraints and so on. Right? And such a framework is Ray Serve, which I asked you guys to learn. How many of you, by the way, went and studied Ray Serve or tried out POC code? Nobody. So today is certainly the day when you should try out the Ray Serve. Are we together? And I will probably in the afternoon walk you through the code. I'll do some code walkthroughs in the afternoon. We'll do that. So instead of fast API, start with fast API, is the baby, is the easy one. Then move over to Ray Serve. Because when you go into production in your company, this is what you will trust. Who are these guys who created Ray Serve? It is the same luminaries who created Spark. Spark came out of UC Berkeley labs, right? Then obviously they went on and did Databricks and all of that. Those same brain trust, a lot of them are now involved doing Ray. Spark was done in early 2010, give or take. This is now 2023, 2024. A fast emerging framework, Ray, right? Now, again, because in this bootcamp, one of the subtext is obviously the job opportunities and so forth. Guys, if from this bootcamp you take away nothing, but you say, I'm a guru at setting up Spark jobs, MLOps, right? Pretty much the heart of MLOps is Spark, is Ray. Sorry, not Spark jobs. Ray, right? I can set up a Ray cluster. I can do Ray Serve, etc. Guess what? There is a 400K a year job waiting for you. Literally. Right? If you want to verify this, one of you go ahead and do this experiment. Go create a LinkedIn profile. Actually, I shouldn't say that. So let's say, hypothetically, if there were a LinkedIn profile which just went and updated, deep expertise with Ray, MLOps framework, setting up Ray jobs, right? Ray executions and control and blah, 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 right? Write it there, wait, take deep breaths, and count how many breaths you have to take before the first recruiter calls you.
100.
Yeah, very, very soon. Literally, the moment it gets noticed, your phone will start ringing, right? Or your emails will start coming for you. Yeah, it is that hot. Why? Because if you look at the distributed compute frameworks, large frameworks, Spark is the king of the hill. It's been around for a very long time. If you look at the demand supply curve of economics, there's a considerable supply of Spark talent. In this room itself, how many people have at least dabbled with Spark in the past? Right? Half the class. How many of you have or know Ray? 0. This is the bridge that takes AI to production, guys. This. If you want to pick one framework that will help you take it to production, it is this. Go master it. The ironical situation is, if you are a PhD in AI, you're less likely to get a job than if you are just a high school pass who has mastered Ray. Yeah. This is the demand supply curve. Okay? This is our situation. And guys, there is a reason every single piece of technology that I have put in your curriculum. See, okay, it's lunchtime. I'll give you a little bit of you guys see me as talking very technical topics, isn't it? AI and this and that, engineering and so forth. There is another aspect of me, which is a subtext, which you don't see, which is that of an educationalist. Education itself is a pretty involved topic. It's a field. It has its own theories. And one of the most creative things you do in education is curriculum development. The goal of curriculum is, given finite amount of time, given an audience, how do you maximize their learning? Right? So every single piece that I'm taking you through in this bootcamp, it has taken me a year to plan and put it there. A year. And I have thought about it over and over again. Should I put it there or not put it there? Is this better or something else is better? So guys, when you do this labs, which you are not doing at all, but if you were doing this lab, I guarantee you, and I mean it, I guarantee you, whatever outcome that you expect from this bootcamp, you will get to it, but you have to put in the effort. So do that. Take Ray seriously. Take all of these things seriously. That is the message I'll give today. I'm not going to teach anything at all today because you guys are behind, pretty far behind. Is that fair, guys? Should we take a breather and just implement today? Right? Yes. Let's go and do the bootcamp part of it. With those words, I'll stop. And you have a question?
Yeah. In this case, the chunking is triggered through API, or I don't know how Racer works, but it is through a trigger, right? Not based on job.
No, Racer gives you an endpoint, REST endpoint. Okay. It just gives you an AI-aware REST endpoint.
Then it means the Spark, which converts PDF to text, is going to make a call.
No. For PDF to text, you don't need AI, so don't make it a Racer job. Only those parts that need AI should be Racer jobs.
So what I'm trying to say is, from that process, we are calling an API
yes.
to trigger the next flow.
You continuously keep saying trigger the next flow. No. Let's go back again. See, you have a Jenkins job. Job number 1, extractor. Right? Its job is to do what? It does a conversion from docs, whatever document format it is, to plain text.
Yeah.
Then it stores it into the database. Right? There is another job that is called this chunker. Right. This is also a Jenkins job, chunker. Right? What is it? It's a Jenkins job. Right. Number 2, let's say. Number 1. Number 2, what is its job? It will read from the database text from the database. It will write chunks back to the database into a table called chunks, let's say, which will have a foreign key back to the doc. But how will it chunk? It will take a text, one text. Let's say that there is a ray serve here. It will send the document over, because semantic chunking needs GPU. Right? It will push the document here, get back the chunks. It will send the text chunks, and it will store the chunks into the database. Are we together? Now, who triggers who? These jobs are completely independent. The triggering part is left to Jenkins, because in Jenkins, you just tie them together that when this job finishes, let this job start. That's all. But in your code, you don't trigger it.
So the chunker itself is calling the array service.
Right. That's right.
Service
that will do the real chunking, which will do the real chunking. That is it. And remember that in your Python code, you never trigger the next one. Let Jenkins do it. Yeah. Which is literally go to the UI, just say this job depends on this job, and that's it. When this job finishes, this should start.
But each job is atomic.
Each job is atomic.
The assumption is like Jenkins will look for new entries in database and all that and figure out, hey, there's a new addition and how does.
No. So the whole question is, what you do is you make the Jenkins, for example, the extractor. keep polling a directory. So every minute it wakes up, checks the directory. If it finds files there, it starts.
Okay.
If there is no file there, it just comes back and says, I'm done. Right? So see what happens is any job, you schedule the job, schedule it for every minute. So every minute it will go check the directory. Are we together? If it finds anything there, it will run. Otherwise, it will return back empty.
And if a previous instance of the job is running, don't start the next one.
It won't start. Automatically, it will queue itself. So that is why, see, there's orchestration engines like Jenkins, right? They have gone through 20 years of maturity. They are extraordinarily good. Every single use case you can think of, they have made it dead simple.
Can we have a tutorial on Jenkins, please?
A tutorial on Jenkins? Sure. After lunch, I'll give you guys a walk through Jenkins.
I was also going to suggest, Asif, seeing that how we responded to the curve that you drew this morning, will also help maybe like, for at least people like me, a basic math class.
A basic math class. Sure,
not as this boot camp, but even as a separate class.
I would love to do that. See, this is one of the things of statistics and so on. Yeah.
Hey,
no,
you're a PhD.
Okay. So the request I'm getting from the audience here, for those of you who are remote, is can we have a session on basic math intuition? Right? So the answer to that is yes and no. It's a little bit hard. If you guys see, this again goes back to the educationalist aspect, curriculum development. What should I put in the curriculum? If you guys can come up with a list of topics you want me to cover, I'll do that. See, the trouble with math is, and I'll end with that. Let me stop the